In this video, we'll cover electron configuration of ions. If you haven't done so already, make sure you watch part 1, 2, and 3 of electron configuration for main group elements, transitional elements, and intertransitional elements. That will help you to understand this portion of the lecture. Let's begin. We're going to begin with a positively charged cation. Cations, remember, by definition, are elements that have a positive charge. Now, you can also have a compound, but for simplicity's sake, we're going to deal with just one element. Say you have calcium. Calcium has an electron configuration of 1s2, 2s2, 2p6, 3s2, and 3p6, and 4s2. That's for a neutral calcium ion. But what about for calcium 2 plus? Calcium 2 plus, plus 2. That means 2 electron has been lost. It's been taken out. A loss of 2 electron, well, where did it lose it from? From the 1s, 2s, 2p? Where did it come from? Well, you're going to select it from remove it from the highest energy level. So which one is the highest energy level? 1, 2, 3, or 4? The highest energy level is at 4. That number 4 in the front of the S or the P, there's a 3 in front of this P. Those numbers represents the energy level. So the highest one here is the 4S. So 4s, and it's going to come, the electron's going to come out from this subscript or superscript here. And so there's 2 electrons there. So those 2 are going to be taken out from the calcium. So that will give me the electron configuration of calcium plus 2. Here's, I'm going to write the electron configuration for calcium plus 2. So we have 1s2, 2s2, 2p6. I'm just writing what's on the top, 3p6. Now, if I take this 2 out, the s2, that means it's going to become 4s0. Well, we don't really write 0 for electron configuration, so we don't write anything. So that's totally gone, okay? Let's try for another element, boron. So here is 1s2, 2s2, and 2p1, and you need for boron plus 3 electron has been taken out and needs to come up from the highest energy level, which are the 2s here. So first it's going to come out from the p, then it's 2 will come out from the s, total of 3. So you're left with 1s2. Okay, now you try for the next one. Copper. Copper has an electron configuration of this. And so what is the electron configuration for copper plus 2? Now look very carefully which one has the highest energy level. It might be tempting to select the 3d9. However, 3 electron configuration is, it's not at its highest. The 4s2, that one has the highest energy level. So you're going to take it out from here. If that is so, then we will get 1s2, 2s2, 2p6, 3s2, 3p6, and we don't have the 4s2 because the 2 has been taken out, and we're left with 3d9. Let's do a learning check. Try these and come back and check the key. And here is the key. I do want to make a note of zirconium, plus 4. Zirconium is plus 4. 2 of the electrons were taken out from the 5s2. Well, the next level over is 4. Either you could take it out from 4d2 or the 4p6. Which one do you select? You select the one that you wrote from the furthest to the right, which is the 4d2. So that will be the next level that you want to take it out from. So hence why it ends in 4p6. Now let's get into anions. Anions are elements with negatively charged ions. And so here's an example, selenium. Selenium has an electron configuration, the neutral one, it goes all the way to 4p4. Now, selenium minus 2, not plus 2, but minus 2 this time, we're going to add, it means to add 2 electrons. So where do we add the 2 electrons? We're going to add it to the highest energy level. Just like you took it out from the highest energy level, you're going to put in to the highest energy level. And so here, the highest energy level is 4s2 and the 4p4. So which one do you add? Well, you can't add it to the 4s2 because S could have maximum holding of 2. P could hold up to a total of 6. So therefore, because there's some vacancy here, it will add on to the 4p4. And so this becomes 4p6. To write out the full electron configuration, I will write as follows. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and then 4p6. I'm adding 2 to that 4 over there. Let's try another one. Fluorine. Fluorine has an electron configuration like this. And fluorine minus 1, fluoride, it just shows that 1 needs to be added. And so therefore, this will have electron configuration of 1s2, 2s2, and 2p6. Let's do a learning check. Try sulfur, sulfide, right, with the -2 charge and phosphide with the -3 charge. And come back and check the key. And here is the key. Here's one thing to know. Sulfur -2, phosphor -3, they have the same electron configuration.